Comet 3I/Atlas appears to be behaving like a fairly ordinary comet, despite a wave of dramatic speculation suggesting that the interstellar visitor may have exploded or broken apart after its close encounter with the Sun. Recent observations strongly indicate that the comet remains intact and active, continuing on its trajectory through the inner solar system, much as scientists would expect from a natural icy body subjected to intense solar heating. While early reports raised concerns about fragmentation, astronomers studying the latest data say there is no compelling evidence that such a catastrophic event actually occurred. The renewed attention surrounding Comet 3I/Atlas intensified after it reemerged from behind the Sun, where it had temporarily disappeared from Earth's view. During this period, the comet reached perihelion, its closest point to the Sun, on October 29th. When it became visible again in early November, some observers noted changes in its brightness and appearance, prompting speculation that it may have lost a significant amount of mass. These claims gained traction after a report published by the science and technology outlet Futurism on November 10th cited calculations made by Harvard astrophysicist Avi Loeb. Using images captured by two small telescopes in Spain, Loeb suggested that the comet may have shed a substantial portion of its material, potentially indicating fragmentation. However, many astronomers caution against drawing such conclusions from limited observational data, particularly when dealing with a comet that has just passed extremely close to the Sun. According to researchers who regularly observe comets, fluctuations in brightness, changes in the shape of a coma, and the appearance of strong jets are all common phenomena during and after perihelion. These effects are often the result of solar heating, causing volatile ices within the comet to sublimate rapidly, releasing gas and dust into space. Such activity can temporarily make a comet appear more diffuse or irregular without implying that its solid nucleus has broken apart. One of the scientists pushing back against the idea of an explosion is Qiqing Zhang, a postdoctoral fellow at Lowell Observatory in Arizona who has been closely monitoring 3I/Atlas. Zhang has stated that all available images show a healthy and intact comet, with no visible signs of nucleus fragmentation. From his perspective, the comet's behavior falls well within the range of what astronomers expect when a comet experiences intense solar radiation. Jets of material erupting from the surface, rather than being a sign of destruction, are a normal outcome of volatile-rich regions becoming exposed as the comet heats up. Comets are often described as cosmic time capsules composed of ice, dust, and organic compounds that formed during the earliest stages of planetary system formation. As they approach a star, frozen materials near the surface begin to vaporize, turning directly from solid ice into gas in a process known as sublimation. The escaping gas can drag dust particles along with it, forming the glowing coma that surrounds the nucleus. Radiation from the Sun then pushes this material outward, creating the characteristic tail that stretches millions of kilometers through space. These processes can vary in intensity depending on the comet's composition, structure, and orientation relative to the Sun. In the case of 3I/Atlas, its interstellar origin makes it especially intriguing. Unlike most comets observed in the solar system, which form from the same protoplanetary disk as the planets, this object originated around a completely different star. Scientists believe it was ejected from its home system billions of years ago and has been wandering through interstellar space ever since. Its estimated age of more than 7 billion years suggests it may predate our own solar system, making it an exceptionally valuable object for studying the chemistry and physical conditions of distant stellar environments. Because of its unusual origin, every new observation of 3I/Atlas is closely scrutinized. The comet's brief disappearance behind the Sun naturally raised concerns, as some comets do not survive perihelion intact. Smaller or structurally weak comets can sometimes fragment or disintegrate entirely when subjected to intense solar heat and gravitational stress. Famous examples include Comet Ison, which broke apart during its close solar pass in 2013. However, many larger and more robust comets survive such encounters and emerge on the other side, displaying increased activity rather than destruction. As 3I/Atlas reappeared, astronomers quickly began tracking its brightness, motion, and morphology. Amateur astronomers also joined in, using small telescopes to capture images that revealed jets of material streaming from the nucleus. These jets, while visually dramatic, are a common feature of active comets. They occur when localized patches of ice become exposed and rapidly vaporize, releasing gas in focused streams rather than evenly across the surface. Such activity can cause uneven acceleration, subtle changes in rotation, and temporary variations in brightness. An image captured on November 9th by amateur astronomers Michael Buechner and Frank Niebling showed prominent jets extending from the comet, which some interpreted as evidence of significant mass loss. Avi Loeb used estimates of this jetted material to argue that the comet would require a much larger surface area than observed if it were a natural object. This line of reasoning fits into Loeb's broader pattern of speculation, as he has previously suggested that some interstellar objects could be artificial in origin. His claims have generated widespread public interest, but have also drawn criticism from many in the astronomical community. Most researchers maintain that extraordinary claims require extraordinary evidence, and, in this case, they see no data that cannot be explained by well-understood cometary physics. The mass loss inferred from brightness changes is highly uncertain, particularly when based on limited observations made under challenging viewing conditions. Factors such as viewing angle, phase angle, and dust grain properties can significantly influence how bright a comet appears, making precise calculations difficult without extensive follow-up data. From Earth's perspective, Comet 3I/Atlas is now climbing higher above the eastern horizon, improving its visibility for observers in much of the northern hemisphere. Under clear skies and with a modest telescope equipped with a 6-inch lens, the comet can be seen as a faint, fuzzy object with hints of a tail. This accessibility has contributed to the surge of interest surrounding the comet, as both professional and amateur astronomers attempt to document its evolution over time. The excitement surrounding 3I/Atlas is fueled not only by its interstellar origin, but also by its rarity. It is only the third interstellar comet ever confirmed, following the discoveries of 1I/Oumuamua in 2017 and 2I/Borisov in 2019. Among these visitors, 3I/Atlas appears to be the most massive, offering a rare opportunity to study a relatively large and active object from another star system. Its size and brightness make it particularly valuable for spectroscopic studies, which can reveal the composition of its gases and provide clues about the environment in which it formed. Many astronomers emphasize that the comet's natural origins should be a source of excitement rather than disappointment. The ability to study material that formed around a different star offers a unique window into the diversity of planetary systems in our galaxy. By comparing the composition of 3I/Atlas with that of native solar system comets, scientists can test theories about how common certain molecules are across the Milky Way and whether the processes that shaped our own planetary neighborhood are universal. As observations continue in the coming weeks, researchers expect to refine their measurements of the comet size, rotation, and chemical makeup. If the comet remains active, its jets and coma will continue to evolve, offering further insight into its internal structure. For now, the consensus among astronomers is clear. There is no convincing evidence that Comet 3I/Atlas exploded or broke apart after its encounter with the Sun. Instead, it appears to be doing exactly what comets have done for billions of years, responding to the heat of a star by shedding gas and dust as it journeys through space. In the end, the story of 3I/Atlas is less about sensational claims and more about careful observation and scientific patience. While speculation can capture the public imagination, the true significance of this interstellar visitor lies in what it can teach us about the broader universe. As it continues its passage through the solar system, Comet 3I/Atlas stands as a reminder that even ordinary cosmic processes can become extraordinary when viewed on an interstellar scale.